Hello students, in this video let us learn about RE model of a transistor. So here we are talking about an NPN transistor, that is a BJT. So it has three terminals, collector, base and emitter. So this transistor can be analyzed or understood using the devices that we already know. Now we know that for the normal operation of a transistor, the emitter base junction should be forward biased, that is this junction should be forward biased and the collector base junction should be reverse biased. Considering that, let us see in the CE configuration. In CE configuration, we know that the emitter is common to both input and output. So where do you apply the input? The input is applied between the base and the emitter. Where do you tap the output? It is between the collector and emitter. The emitter being common to both input and output. Now since the emitter base junction is forward biased, let us draw the input characteristics. Let us see how the input characteristics looks like. So what is the input characteristics? It is a graph of input current IB versus input voltage VBE. So when you look at this curve is similar to that of the forward characteristics of a diode, isn't it so? So that is same as your base emitter junction. So in this diagram, which we called as the DC model of a transistor, the emitter base junction is replaced by a diode. Okay. Now let us see what is the importance of this. So you all know how a constant current source is represented, isn't it? So you have a circle and you have an arrow mark. The arrow mark here indicates the direction of conventional current. Now look at this characteristics. So what is this? This is the output characteristics of a BJT. So in a BJT, so again you are having a graph between the output current IC versus output voltage VCE. So what do you observe? You observe that initially with change in VCE or with increase in VCE, IC is increasing and then remaining a constant for a particular value of IB, isn't it? So we need to concentrate on this area of the characteristics. What do you observe? Look at this one curve, that collector current remains constant irrespective of changes in voltage. That is true even with IB2, that is also true with IB3. So what does this mean? So to put it in a statement, the output current remains a constant irrespective of changes in the voltage across it. So this definition, if you remember, in the first semester we have learnt that a constant current source is defined as the one which gives constant output current irrespective of changes in voltage across it. So don't you think that definition holds good for the output characteristics of a BJT? That's why the collector base junction, in between the collector and base, you have a constant current source. But please note that the arrow is downward. So here also you see that the arrow is downward, meaning to say that is the direction of conventional current and electron current is just opposite to that. So this is the DC model of a BJT. So what is it? To wrap up, between the collector and base you have a constant current source because the current remains constant irrespective of changes in the voltage. Then the base emitter junction is replaced by a diode because the input characteristics is similar to that of the forward characteristics of a diode. Students, whatever we are learning here is in the chapter voltage amplifier, and you all remember that voltage amplifier is also called small signal amplifier. Why is it called small signal? Because the input is small. So if you remember students, in the last a short while ago we have drawn the characteristic between IB and VBE, isn't it? So what is this? This is your input characteristics. So students, this was the forward characteristics of a diode, yes or no? So we know that an amplifier increases the strength of a weak signal. Where do you apply the input to a CE amplifier? It is between the base and emitter. So students, depending on the Q point that is set, see the variation, the signal that you are applying is in the order of millivolts. So, since the voltage is in millivolts, the variation in current will also be very small. And what I want you to understand here is the current, the base current will not be varying throughout this graph. So, what I was telling you here is, because we are talking about a small signal amplifier, the variation in base current will not be throughout this curve. Instead, it is limited to only a small portion of this curve. So, how do we do? So, this is a plot of I and V. So, if you are talking about only this part, you see that this is almost a straight line, and this part can be considered, the slope of this part will give you the resistance. Now what? See this diode, okay, the diode is represented by the forward characteristics. Since the entire region of the characteristic is not utilized in a small signal amplifier and we are using only a small portion, this portion, see this part will give you delta VEB and this part will give you delta IB. So, delta VBE by delta IB will give you resistance. We know that according to Ohm's law that V by I is R. So, this diode in the model that we studied a short while ago will now be replaced by something called as resistance. And what is that resistance called? That is represented by RE dash. Please note students that it is in the lower case. Now, why it is in the lower case? In the class we have been studying that all AC quantities are represented in lower case and all DC quantities are represented in upper case. So, what is it? So, you are representing a diode, you are replacing the diode in the DC model by a resistance, and that resistance is called AC emitter resistance. And please note, this is not the same as your stabilizing resistance capital RE. So, please be careful, and this is a resistance of the base emitter junction. Don't search for a resistance hanging out in your BC 107. So, it is actually a representation of the base emitter junction as a resistance. So, this is the RE model or the AC model of the BJT. Another name for this is that this can also be called as the T model of a transistor. So, if you just shift it, it also looks like a T. So, this is about the RE model of a BJT.